So we'll begin with problem 16 now. It says if Sn, which is the sum of all terms from 1 to n, is given by 1 by 6 into n into 2n square plus 9n plus 13, then we have to find the value of summation 1 to n root of tr. So basically we have to find the sum of the square roots of all the terms from 1 to n.
This is one category of questions wherein we are given the sum, the expression for the summation thing,
Right.
but as in here we are supposed to find summation root of tr.
Okay.
So here we have no other option, we actually have to find tr so that we can later take its root.
Right.
Okay, so here we define that tr is defined as Sn minus
Sn minus
Sn
1.
minus
Correct.
1 Tn. Okay, for all n greater than equal to 2.
Right.
So here this means that the sum for the nth n terms minus the sum for n minus 1 terms. Obviously that is the nth term itself.
Right.
Okay, so here we see that we know the formula for Sn. Okay, so similarly we could find Sn minus 1 by just replacing n by n minus 1.
Correct.
So here we see that Tn is equal to 1 by 6 into 2n square plus 9n plus 13 minus 1 by 6 into n minus 1 into 2 n minus 1 whole square
Right.
plus 9 into n minus 1 plus 13. Okay, so this way just solving it,
We get an
we at the
expression
end
for
we
Tn,
get 1
which
by
is
6 into 6n square plus 12n plus
Okay.
6,
Yep.
that is n plus 1 whole square.
Right.
So basically this is our Tn.
Tn.
Now what we are supposed to find is that is root Tn, which is obviously
N plus 1. Correct.
And now finding sigma root tr r is equal to 1 to n, not a difficult work. That
Right.
is sigma r is equal to 1 to n r plus 1.
Right.
Okay, that is half into n plus 1 into n plus 2 minus 1.
Right.
That is half of n into n plus 3, and that is the C option.
Right. Okay, again, a very simple problem eventually, but we started out and we were scared because there was an under root with tr, so we proceeded to find tr because there is no way we can go from summation to under root. So we found out tn by using Sn minus 1, which is very obvious, and we arrived with an expression for tn, and then we found out that it was a familiar and simple expression. Whenever you see a very complicated jump from one concept to another, it usually involves the use of very simple variables, and that is why I could have actually figured out very easily looking at the question that I will eventually get Tn to be very simple, which will be actually a perfect square, otherwise the question would not make sense. Okay, so that was problem 15, actually problem 16, so we'll move on to 17 now. So we have come to the end of practice problems for the chapter sequence and series. This is problem 17. It goes like this. If cos of x minus y, cos x and cos of x plus y are in HP, then value of cos x into sec of y by 2 is what? So we're given 3 trigonometric expressions. We have to find the value of another one. So it involves a mix of some trigonometry and progressions.
Exactly, and here again we'll just apply the basic concept of harmonic progression. Now as these three terms are in harmonic progression, so obviously their inverse is going to be in AP.
Right.
Okay, so we just start with that.
Okay.
That is 2 by cos x will be equal to cos of x minus y
Right.
plus cos of x plus
So
y.
we have our starting equation.
Exactly. Pardon.
Right.
So after that, we'll just take the denominator common and we'll just solve for both the sides.
Okay.
This side we get on multiplying in the denominator we'll get cos x plus y into cos x minus y.
Correct.
Okay. We'll just bring it to the left side. That will
Okay.
be 2 into cos square y minus sin square y.
Right.
And there, in addition, we had cos x plus y plus cos x minus y.
Correct.
That is cos x cos y.
Okay.
2 cos x cos y.
Right.
And bringing this cos x to the right side, we get 2 cos x
Cos y.
into cos x cos y.
Correct.
Okay, so now this is a pure trigonometric question. The work of progression here gets over.
Right.
And here we get just multiplying, we get cos square x is equal to 1 plus cos y, multiplying and solving.
Right.
So this is equal to 2 cos square of y by 2.
Okay.
Okay, thus we know that cos y by 2 is obviously 1 by sec y by 2. So cos
Okay.
of x into sec y by 2 that will be equal to plus minus root 2.
Right.
So therefore answer is A part.
Okay. So again, as we told you, this involved a mix of those two areas of trigonometry and progressions. So we had a starting equation from the condition for harmonic progression, and from then on we just manipulated. It was a simple job to find out an expression which satisfied, which was of the form of the question, and we got it in about 3 steps, and the answer is plus minus root 2, which is one of the options. And so because our approach was correct, the answer is probably correct. So that was problem 17, and that is it for sequence and series.